Okay, it's online.
All right. Welcome, students of the compiler theory and practice class. We have our Google Hangout here this week with Chow. Nam is in a different time zone, so he will be able to join next week onwards. He's not here today. Um, but we are here to take any questions that you may have and also check on things, how they are going. And I'll start with announcements as usual. So I hope all of you are pacing properly through the videos, the lecture videos, and also trying to read the corresponding material from the book. So the book material may not be exactly in correspondence, maybe slightly different or more than what we cover in lectures, but please follow reading that text along with the looking at the videos, and that will give you a very good understanding of the subject. So I hope you all got a very good idea of the compiler front end pacing through the videos on the Udacity, and you must have also finished the initial part of regular expressions, the way they look and what they specify and so on, and why we have those. So the whole idea here is to be able to just write the specification and automatically generate the scanner from it. And in fact, not only scanner, but the parser is also generated in an automated way from the grammar, and that's what we'll be covering next once we finish the scanner. And the regular expression specifies how the tokens look like. So please practice some of those examples which are on the slides, also in the book, of how to go about writing regular expressions. Next week, we'll be doing some homework related to those. So to recap, again, regular expression helps us to just focus on writing the specification, and that is automatically converted into a scanner by the scanner generator. The theory behind the conversion, which is NFA. So the regular expression is first converted to non-deterministic finite automaton, and from there the NFA is converted to DFA. That's what we are going to see in forthcoming lectures, and that is how the scanner is automated. And scanner generator is yet another compiler which reads the scanner, the lexical specifications in the regular expression form, and it converts it into the code which implements the scanning. So that's the translation again from a higher level language, like in regular expression form, to its implementation, which is the scanner in the lower level form. So the DFA and NFA allows, those concepts allow us to use finite state machines to implement these regular expressions. So the lecture slides also show you that not everything can be captured in terms of regular expressions. For example, the problem of matching the parentheses is not capturable by using regular languages, and that's why we postpone it to the parsing stage. Similarly, not all problems are syntactically oriented, such as checking the declarations of variables and their type matching and all this, because they cannot be specified by a context-free language, and that's why we postpone them to semantic analysis, which is context-sensitive. So we do more and more amount of processing as we descend down in the compiler phases. And of course, the amount of information that is used by those phases becomes smaller and smaller. For example, we don't do semantic analysis on all the tokens. We do it only on the identifiers and constants and such. For example, the semicolons, commas, those are simply delimiters, and we just verify their syntax and then move on. But we don't, as such, do any semantic processing on semicolons, tokens such as semicolons or comma, etc. So that's what brief announcements are. We'll start also teaming up for the projects, and I got some individual requests. I'm going to take a look at those and respond. In general, we are supposed to do all this in terms of teams because the work is substantial, and also this is supposed to be a team experience. How to work on a large-scale software in as a part of the team, because that's exactly how things are in real world. You will be a part of a larger team, and you will be working together along with others. So we'll try to stick to those things as much as possible under really exceptional circumstances, which I will take a look at. If you have a request for me, I'll evaluate it and will get back to you about it for doing it individually. Other than that, I think we are in good shape. Chow, do you have any announcements to make at this point?
No.
All right. So I think then we probably should take some questions. And Chow, are there questions which should visit, or are there any questions from those who are at the Hangout now?
Currently, I have no questions from the Piazza. I think the only thing is about somebody asking to do the project by themselves. I think we discussed through the email. I saw an email discussion between you and Nam.
Okay. Yeah, sure. So Nam has forwarded me a few requests, I think 3 of them so far, and we should discuss those. We'll discuss those and get back on those in the next few days. But other than that, are there any conceptual questions? Are there any questions? Oftentimes, students confuse between what is scanner's job versus what is parser's job. So I would like to clarify a few things. The scanner's job is to really deal with tokenization. That is the main job of scanner. So how to group these characters together to form token and send them to parser. That is the main job description for the scanner. And in that process, of course, it ignores or gets rid of white spaces, tabs, new line characters, etc., or comments, which are really not relevant for the parser in terms of processing the program. All these things are present for our benefit, the human readability of the program. But as far as the semantic meaning of the program, as far as the syntax of the program, they don't have any bearing. So those are just discarded by the scanner. The rest of them are, of course, processed and sent in terms of tokens. And then tokens also carry along with them. I just want to mention, as you'll see later, or I might have already guessed this, some tokens carry more information than the others. For example, variables or identifiers. The fact that they are var or ID is the token type, class, var or ID. That's one piece of information. Second piece of information they carry is exactly what is the name of the variable. And the name becomes important not for the parser, but as you can imagine, it becomes important for the semantic analysis purposes to install it in symbol table during its declaration, and to actually check it if it is already declared, and to check its type, etc., during the semantic processing. So that's why the tokens such as identifier have to carry 2 pieces of information. Tokens such as floating point constants, they will also carry the name of the token, which is float constant, and also the value, exact value, because that is the value which we have to use during the code generation. And so that is also sent by the scanner. Whereas some other tokens, such as delimiters, such as comma, semicolon, they don't have any other information associated with it. So in other words, they have no semantic information, and so they're simply used just by themselves as a token name, and then are used by the parser for matching, and then they are discarded once the match happens. So that is what happens there. And then the parser, as you have seen through this first week's videos, once it sees enough part of a sentence, it will do some checking on parts of the sentence in terms of, for example, sub-expression, whether it is type compatible, the two operands. It will carry out the checks using semantic analysis, and then also carry out its translation into an IR and keep doing this activity on seeing a part of the sentence. There are lots of semantic activities. We have shown some, and we'll be also dealing with some of them in details later on. So this type of working of a compiler is also called as syntax-directed translation. It's for ease of understanding. In real-world compiler, there is a slight difference to this. What really happens is we construct the abstract syntax tree, which is how the sentence looks like. So start with the parse tree and convert it into parts of speech, such as this is an identifier, that is an expression, and so on. And then for each part of the speech, we will have the parse tree for it, and then the abstract syntax tree, which has two operands and an operator. And the parser and scanner work together and just create this representation. And then there is a separate semantic analysis phase, which runs on this representation and converts that into a quad IR. We'll be doing a project which will be using this type of philosophy based on Antler. Most production compilers are written this way, that they will first create from source an IR which is in the form of a parse tree and an abstract syntax tree. Abstract syntax tree is different from parse tree in that it just worries about the operands and the operators and their precedences, and not really how the grammar's parts of speech are sort of derived or derives them. That information is not present because as far as the code generation is concerned, we are only interested in what is the operator precedence, how the two operands are combined, and their hierarchy in terms of a tree, which is AST, abstract syntax tree. And that is the one which is used for converting into quad IR, and from there, certain optimizations, some analysis on them, and then from there do register allocation, instruction selection, and code generation. So that's typically the practice, and we'll be doing a project which is related to that. It's exactly one and the same thing. In syntax-directed translation, it occurs interleaved with parsing, and the parser calls the semantic analysis on bits and pieces of the sentence once it finds them syntactically correct, and then goes ahead and translates it. Whereas in the AST level approach, we don't do any checking at all, which is interleaved with the parsing. We just completely generate the whole parse tree in AST and then make passes over that to do the semantic validation checks and then convert it to the quad. That's the only difference, the way it is done. You might ask me, why is it that we do the AST in practice? Because many times for doing semantic processing, you might need the right context. And if your parsing is going on from left to right, you may not have the right context available, okay, in terms of performing the semantic checks. So that is why you first develop the whole AST, let all information be there, and then the semantic analyzer will use the necessary information from the left context or the right context to carry out the semantic checks. And if you don't have the right context need for right context to do the semantic checks, then you can just do syntax-directed translation. And that means that you have seen a part of the sentence on the left-hand side of the rule, and you can just do full checks on that without worrying about what is lying ahead on the right side. So that's the reason most languages, practical languages or full languages, need the whole sentence to be present before you can semantically analyze it. And that is why the AST-based approach to expose the whole right context as well, build a complete parse tree of the full sentence, and then actually process it for semantic validation. Some small subset of languages do not need the right context, and so we could just get away by doing the semantic validation on whatever we have seen thus far using syntax-directed methods as we are looking at in the illustration. Okay, so that's one kind of explanation. So as I was explaining, have some questions come up, or are there any other questions at this point?
No, I think I posted an announcement a little bit late yesterday. I will post it today for next.
Yeah, so I think we'll be keeping those who might not have seen this announcement, but they will definitely look at this, our Hangout recording. Every week we are going to pretty much keep the Hangout from 3:30 to 4:30 without changing the time from week to week. So even if you did not get announcement, please assume it's there at this time. Of course, we'll try to post it ahead of time, as Chao is pointing out, but sometimes we might get delayed or something, but this is the time for the Hangout. All right. We'll wait for some questions. This is also a long weekend, so many folks might be traveling with their friends and family. So we'll see what happens. But if you have any questions, those who are on the Hangout of any kind, please do not hesitate. So for next week, pacing, we have NFA DFA conversion. Again, regular expression will be able to directly convert small piece by piece to NFA, non-deterministic finite automaton. So it is a direct translation. Each regular part of a regular expression we can generate a very simple NFA, and we can compose them and put together a large NFA. That's why we have NFA in the first place. And then we do the NFA to DFA conversion, which allows us to really implement the scanner. The scanner has to be in a deterministic format because we don't want to do backtracking and we don't want to spend too much time in doing scanning. So determinism really helps. We are able to move forward without trying to go in one direction and reaching a dead end and then coming back and trying another direction. That is what the NFA implementation would do. So that's the main reason to convert from NFA to DFA. And we'll also be getting something free there. As you see those videos, we would have most optimized DFA, which is smallest in terms of number of states. So we are going to look at that particular algorithm, which is used for NFA DFA conversion, which also minimizes the number of states in the DFA in this particular lecture. And so please go over this. Again, some of the homework will cover some of these topics or all of them. It's using some homework question to give you some nice practice. Yes, there is a question on the Hangout about the homework and the project. Um, the homework, we are going to go ahead and release homework one. The project, it will be slight delay because of the TAs traveling and long weekend. I think early next week is when we plan to release the project phase one. So hold off a little bit on that. This was a tentative date, 8/31, but we'll go ahead and do the homework, and the project, there will be slight delay of 3-4 days uh, when we'll be releasing the project part one. In the meantime, I think the recommended size of teams um, we had was 3 students per team. So please go ahead and find your partners using Piazza. If you need any help, then let the TAs know, and they will help you get into a team. Again, there will be slight delay in terms of releasing part one of the project, but the homework we are going to go ahead and release by tonight. Okay, looks like we'll wait for some questions. Brian, thank you for your question. And if there are any other questions, I'm going to mute myself a little bit in my office to avoid noises coming from here. And if there are any questions, then I'll unmute and answer those. Hello. So I'm back.
Yes.
I hope, are there any more questions, Chao?
No.
All right. I think looks like everybody might be busy for going for the long weekend or so, and um, we'll again reconvene next week, same time, and we'll be going ahead and releasing the homework and 3-4 days the project next week, and have a wonderful long weekend. And since there aren't any other questions, let's conclude for today, and see you next week.
See you.
Thank you.
Bye.